The NASA Parker Solar Probe made unprecedented and record-breaking flights through the solar corona in December 2024, capturing the closest images yet of our host star. NASA released these remarkable images taken from just 6.1 million kilometers away from the sun's surface. They provide insights into crucial features of solar wind, helping scientists understand the origins of this mysterious phenomenon and its effects on life on Earth. Solar wind is a continuous flow of charged particles, primarily protons and electrons, released from the sun's outer atmosphere, known as the corona. This mass stream travels at speeds exceeding 1.6 million kilometers per hour through the solar system, contributing to phenomena such as auroras, atmospheric erosion on planets, and electric currents that can damage Earth's power grids. Understanding and predicting space weather is vital for protecting astronauts and spacecraft, as well as minimizing disruptions caused by intense solar activity on terrestrial infrastructure. The Parker Solar Probe, launched in 2018, is the first spacecraft to enter the solar corona. It's equipped with a suite of scientific instruments, including the Wide Field Imager for Parker Solar Probe, WISPR, and the Solar Wind Electrons Alphas and Protons, SWEAP, detector, designed to withstand extreme heat and radiation while sending precise data about the Sun and its surrounding environment back to researchers on Earth. During its record-setting close pass on December 24th of last year, the Parker Solar Probe captured images demonstrating how solar wind behaves shortly after emerging from the Sun's corona. It also recorded interactions between unpredictable plasma bubbles and magnetic fields, known as coronal mass ejections, CMEs. Anjali Verlidas, the lead scientist for the WISPR instrument at Johns Hopkins University Applied Physics Laboratory, noted, there are two types of solar wind: the fast solar wind, which moves up to 800 kilometers per second, creating a relatively steady stream of material. In contrast, the slow solar wind is denser and more unpredictable, blowing in intermittent bursts. Close to Earth, we typically experience solar winds more as a relatively steady breeze. However, previous data from the Parker Solar Probe indicated that as we get closer to the Sun, these gusts intensify and are accompanied by greater turbulence, like zigzagging magnetic fields known as switchbacks, identified about 23.6 million kilometers from the Sun's surface. Switchbacks likely originate from magnetic funnels created by visible sunspots. In 2024, scientists reported that fast solar wind is partly fueled by these phenomena. Meanwhile, the slow solar wind, being denser and more variable, remains mysterious. Noor Ravahai, a scientist on the Parker Solar Probe project from Johns Hopkins University, stated, "The big question has been, how is solar wind produced, and how can it escape the sun's immense gravitational pull?" Understanding this continuous flow of particles, especially given the diverse characteristics of these streams, is a significant challenge, but with the Parker Solar Probe, we are closer than ever to unraveling their origins and evolution. Previous observations suggested that there are likely two types of slow solar wind: alpha-Nic, which contains small magnetic switchbacks, and non-alpha-Nic, which does not. The Parker Solar Probe confirmed this long-standing hypothesis with its latest pass. Additionally, the new detailed images have improved scientists' understanding of the origins of these distinct phenomena. Alpha-Nic wind likely originates from coronal holes in cooler regions of the Sun's corona, while non-alpha-Nic winds may be released from hot magnetic loops known as helmet streamers. The Parker Solar Probe will continue to gather data, with its next periapsis passage, the closest point to the Sun's surface, expected on September 15.